Hello, I'm Erin McGill, and I'm going to be talking to you today about containerized applications with AWS Fargate. So we're now in a time where more and more development teams are utilizing containers for their applications. With containers, you can easily build microservices with a lower footprint. You can lift and shift workloads around across environments or across data centers, or you can run batch jobs in an efficient way. So the portability that you get out of using containers is a really big win. And you can actually run many containers simultaneously, and you can bin pack them on a host to more efficiently use the host resources to get the best out of your infrastructure investment. But you still have to run them on virtual or physical machines. And to scale to hundreds or thousands of containers, you need to run at least a few hundred hosts, and you have to manage those hosts. You'll have to find the appropriate image hosts for those containers that you want to run. You have to manage the container cluster state, and you have to detect failures and so on. And that's where a fully managed container orchestration platform like ECS enables you to do just that. So ECS enables you to operationalize your containerized workloads at very high scales. You have no management software to install or worry about its high availability. So within ECS, you have a few components. The cluster management piece, that enables you to monitor the cluster, to scale it to using auto-scaling groups, and to be able to manage the state of the instances in the cluster. The placement engine, that enables you to be able to set rules and constraints to target landing your containers on the right instances based on what your workload needs and what it requires. And then finally, you have the advanced scheduling features that help maintain the desired state of the application, allows you to spawn new containers automatically and maintain the resiliency by deploying across multiple availability zones while still being resource aware of the underlying compute. Now, let's take a look at what you're really managing with that container management service, because really you end up managing more than just containers. If you double click on the instances, it reveals that there are additional supporting software such as the Docker agent or the ECS agent and your operating systems that you have to have running and to maintain and patch on all of your virtual hosts to support those containerized workloads. So the real picture of your clusters looks something like this. So these are the additional layers that you have to manage in addition to your containerized workloads. So in Fargate enables you to run an ECS to run your containers without needing to manage the underlying hosts and those additional layers and components. And AWS Fargate is a compute engine for AWS Amazon ECS. It allows you to run containers without having to manage the servers or clusters. With AWS Fargate, you no longer have to provision, configure, and scale your clusters of virtual machines to run your containers. It removes the need for you to interact with or think about the servers and clusters, and it lets you to focus on designing and building your applications. So AWS Fargate is a new technology to run containers while AWS manages the underlying infrastructure. Fargate allows you to work entirely with an ECS task native API. So with Fargate, you specify the container image, the CPU and memory requirements that are needed to run your container in an ECS task definition. And with that single command, you can run that container in production or in development or test. And with one command, you can scale it to tens, hundreds, or even thousands based on your production or workload requirements. So I just wanted to take a look at the current landscape of the container offerings as managed service in AWS. So as you can see, we have the management services such as Amazon ECS or the Elastic Container Service, or Amazon EKS, which is the Amazon Elastic Container Service for Kubernetes. So these are the orchestration platforms or orchestration services in which you are going to launch your containerized workloads. And then next we have the hosting mechanisms or the launch types for these workloads. Now today, Fargate launch type is only available for Amazon Elastic Container Service. It's designated to work with ECS and the core APIs, the core AWS APIs, with scheduling and placement concepts remaining the same. And you can continue to benefit from the investments that we've made in ECS over the past 3 years with access to the same rich set of features and capabilities to run in production at scale. And I'd like to say that announced as of October 29th, Fargate is now available in the London EU region. So let's dive in a little bit deeper into how to actually use Fargate. First, we'll talk about the constructs with using ECS. So Fargate in itself does not introduce any new constructs, and it works seamlessly with the ECS orchestrator. So the constructs that we're going to discuss are ECS ones. So within this diagram, we have the key concepts of ECS. We have the task definition. This is the blueprint for our application. It's the configuration for a container to run as part of a task, and it defines the attributes of the container, including port mappings, resource requirements such as memory and CPU, environment variables, anything you really need to run your task. Then we have the cluster, which is the logical grouping of tasks and services. And this infrastructure may be shared between tasks and services running on the same cluster. And then we have the task. The task is the instantiation of the cluster described within the container described within the task definition. And then you have the service. The service maintains a specified number of running simultaneous instances of a task definition in an ECS cluster. It's also integrated with the Elastic Load Balancer, so it can ensure that it directs traffic to the healthy containers that are ready to receive the requests that are being sent to that specific task definition or that service. AWS Fargate supports multiple container registries, the Amazon Elastic Container Registry, as well as public and third-party private repositories. And Fargate does not restrict you to a fixed resource size. So it gives you the flexibility to meet what your application needs to run best. And it provides a wide range of CPU and memory configurations for your workloads. And the billing is on a per second granularity. And you configure and pay for the task level dimensions independently. And you only pay for what you provision. In other words, you pay per CPU second and per gigabit second for memory. With the networking, networking is a little bit different when using Fargate than it is with a traditional containerized environment. So right here we have a subnet defined within a virtual private cloud. We want to launch our Fargate task within that subnet. So when this task is launched, we also create an Elastic Network Interface, or an ENI, that has an IP address that's scoped to that subnet in which you launch your task. Then that ENI is directly attached to that running task. And the task ENI is used for all inbound and outbound network traffic to and from your task. So with this task ENI, your running task is directly accessible from within your VPC and directly addressable from within your VPC. You can also assign a public IP address if your workload requires it. So because of the task ENI, you can configure security groups to control inbound and outbound traffic. For storage, the EBS-backed ephemeral storage is provided in two forms, in the writable layer and as volume storage. So with the writable layer, Docker containers, they consist of immutable image layers with the topmost layer a writable layer to capture any information that's written during the run of the container. So for example, logs or any error messages. So Fargate provides 10 gigabit layer storage that's available per task across all of the containers. Now keep in mind, this layer is not visible across the containers, and it's also ephemeral. So that means when this task stops, that data is no longer available. So for volume storage, if you need to have writes that are visible across containers for things like monitoring containers that run in conjunction with your application container, Fargate provides 4 gigabyte volume space per task, and you can configure this task, each of these tasks to mount within the different container paths, and you don't need to specify a host source task. And these are configured via the volume mounts within your task definition. This is also ephemeral. So once these tasks stop, this data is no longer available. So for the IAM permissions, IAM is your cluster boundary now. There's no longer a capacity boundary and a management boundary as far as the ECS cluster is concerned. So there are permissions that you can control at 3 different layers when it comes to managing your Fargate environment. You have the ECS cluster level permissions. They enable you to control which users can run applications in the cluster. So if you have the same set of applications running in development as you do in production, you can separate their user permissions based on the environment that they should have access to. Secondly, your applications may need to interact with other AWS resources, such as an S3 bucket or a DynamoDB table. These resources have to be accessed or need to be accessed as an IAM user. So this task IAM role runs your containers as an IAM user so that you can access these resources. And then lastly, you can give ECS the ability to perform certain actions for your tasks, like sending logs to CloudWatch or to pull an ECR image. We call this role to perform these actions the task execution role. And all of these permissions apply to both the EC2 and Fargate launch types. So great, AWS is now managing your host when you use Fargate. But with this, how do you ensure that your production workloads are running and performing as you expect them to? You do lose a little bit of the ability to use traditional methods that we are used to using to help us monitor and troubleshoot issues within your clusters by not having direct access to your hosts. However, Fargate provides multiple dimensions for visibility and monitoring within your tasks to ensure that they are performing as you expect them to. So ECS Fargate is integrated with CloudWatch logs, and you can view the logs directly within your task detail page. And then we have the container health checks. The container may be running, but its health is not necessarily the same as uptime. So ECS now supports Docker container health checks. And these health checks give you more control over monitoring the health of your tasks and improves your ability and the ability of ECS services to ensure your services are healthy. So in addition to supporting Elastic Load Balancer health checks, Amazon ECS can use these Docker container health checks to allow you to explicitly define and monitor the health of each container. And then we have task metadata. This is information about your cluster and your task level information. So if you don't have access to the instance, how do you detect which containers are running and what are they running in the task? You have to query from within the task itself. Also, How can you tell what image was pulled and when it started running? So for example, why did the startup take so long? The task metadata can provide this detailed information for you. You can also look at what's going on within the task, which containers are using the most CPU or memory or compute sources, and that Stats API provides you that detailed information. And is this task metadata that Datadog is able to consume. They consume this information and it can display this information in a dashboard in an incredibly consumable way. You can also apply Docker labels in a task definition to auto-detect your application. And with that, I'd like to thank you very much. I'd like to hand this over to Waldo Grunenwald, the evangelist from Datadog.
Thank you, Aaron. Welcome to monitoring your containers in AWS Fargate with Datadog. You could say that it's a match made in the cloud. Hi, I'm Waldo. I'm a technical evangelist for Datadog. This means I get to travel and be an advocate for our users and communities. I'm a recovering ops engineer, a raging introvert, and I actually enjoy public speaking. I've also been actively involved in the DevOps community for many years. Now, while I'm not terribly interesting, my company is. As I mentioned, I work for Datadog, where we offer a SaaS monitoring solution which processes trillions of data points per day. One of our sayings is, storing data is cheap. It's not having it when needed that's expensive. We're also open source collaborators and are actively involved with our community. Finally, we're actively hiring, so if you're looking for a new career solving challenging problems and helping other people monitor their systems, please have a look at our jobs page. You almost certainly know us for our infrastructure monitoring products, and in the past year, we've also released APM and logging tools. We use all the same infrastructure that you do, and have to deal with the same problems that you do. It's for those reasons that we choose to operate in the cloud. Likewise, we enjoy the benefits that deploying applications as containers, just like you, and we have the same challenge of deploying and running them at scale that you do. It's one thing to build your app, put it in a container, and Docker run, but it's a whole different case to run your containerized application at scale, and to manage inter-application communications, whether you're running a moderate SOA or a full-blown microservice architecture. It is for this problem that modern container schedulers such as Apache Mesos, Docker Swarm, and Kubernetes are used. When I first came to use Kubernetes, it was at a Kubernetes consultancy where we ran customers' highly available staging and production K8s clusters. I found that Kubernetes is what I've wanted for a long time, a system that lets you put your applications on a pile of compute without having to manage what piece is running where. The problem is that Kubernetes itself is a complex environment. It requires a non-trivial amount of expertise and experience to run and maintain. Amazon EKS makes this easier, but you may not want or be able to commit even that amount of engineering time. To quote Amazon, AWS Fargate is a compute engine for Amazon ECS that allows you to run containers without having to manage servers or clusters. With AWS Fargate, you no longer have to provision, configure, and scale clusters of virtual machines to run containers. This removes the need to choose server types, decide when to scale your clusters, or optimize cluster packing. AWS Fargate removes the need for you to interact with or think about servers or clusters. Fargate lets you focus on designing and building your applications instead of managing the infrastructure that runs them. This is great for teams that want to spend more time getting their apps running in the cloud quickly and easily. I hear you ask, what about monitoring guy? When running Kubernetes, you can add the Datadog agent container as a sidecar in your application pod. This pod is directly analogous to the Fargate task definition. But you're much better off running the Datadog agent as a daemon set on each of your K8s worker nodes. This provides monitoring for all the pods running within your K8s cluster. The problem here is that by simplifying the environment that you work with in Fargate, you don't have as granular control that you might have otherwise. In this case, you don't have the equivalent of a daemon set on which to run your worker node, and you cannot run docker exec or kubectl logs, which might leave you feeling a little helpless and blind if things should go wrong. In fact, with the exception of CloudWatch, you might feel that you don't have much insight into how your applications are performing at all. That's where Datadog comes in. Fortunately, Datadog is a longtime partner of AWS, and we've been working together for a long time to solve this problem. In fact, we were a launch partner. Since version 1.1.0 of the Fargate platform and version 6.1.1 of the Datadog agent, we've been able to integrate with the task metadata endpoint so you may collect real-time, high-resolution metrics from all of your Fargate tasks. Datadog agent checks can now be automatically configured thanks to auto-discovery. Making use of this integration is simple. The Fargate task, again, is analogous to the Kubernetes pod. In order to add monitoring to your task, you add the Datadog agent container to your task definition. Here, I'm going to show you how easy it is to integrate Datadog with your existing Fargate task definition. First, we open our existing task definition, and we're going to create a new version. For this, we simply want to add another container. In order to make this work for us, we need a couple environment variables. First, we need to set ECS Fargate to true. And next, we need our Datadog API key. We select Add, and you see a new container has been added to the container definition of your test definition. So we see a new version of our test definition has been created. Next, we need to go back to our cluster and update our service to use the new version of the test definition. You can see we're currently running version 3. There had been some intermediate steps that have been cleared out, but what we just edited was version 6, so we're going to set that. We're pretty happy with how things are configured right now, so we're not going to make any changes. And just have a quick look over at the review page, and everything looks good. So we're going to, in no time, our service is updated. So looking at our current deployments, we see the existing service is still running all 3 of its pods, and the new service has been created with a desired count of 3. We do a refresh and we see the pending count goes to 3. And over time, those pending will turn into running instances. There we go. So let's go to our Datadog dashboard, and we can watch containers start to check in. Here we have, we can see the task definition version 6. We have the Datadog agent pods. The internal ECS pods are containers that help manage your task definition, and our demo Nginx pods. Well, you can monitor individual containers. You want to use your newfound freedom to monitor your containerized application in the aggregate. Once you have containers reporting in, you'll probably need to filter what is useful to you at the moment. Let's look at our application copy shop by filtering the rest out. Now we see just the containers that relate to this cluster. You can see your defined aspects to filter to groups. This view is useful for seeing information about particular containers. Because containers are expected to be ephemeral, more often you will probably be more interested in your application as a whole. For that, you'll want to use dashboards. Datadog provides you with default dashboards based on the integrations that you've enabled. Additionally, we find that our customers begin building their own dashboards organically. For instance, in this dashboard, this team found that displaying things like their slowest loading pages, container launches per second, and error anomalies together on one dashboard useful for correlating behaviors to diagnose problems. Dashboards are great for working on problems, but when things aren't broken, you have other work to do. Dashboards help you to achieve a lower mean time to repair by correlating information. Likewise, you don't care about individual containers, but when there's a problem in the aggregate. For this, we'll use monitors to let you know when there is a problem. This monitor, for instance, alerts when a process takes too long, but rather than using a static threshold, it leverages anomaly detection to determine when to send an alert. Our APM tools give you the ability to see many different levels of observation. Here at the service list layer, you get a high-level view of how your instrumented applications are behaving. Here we can see aggregates of our application behavior, hit-to-error ratios, types of errors, latency, and so on. Further down, we can select a specific error to get more detail, including linking directly to the relevant logs. I'm going to look at this request for Cupcake, because it is returning a lot of errors. Looking at this specific trace here of an application running inside a container, APM still provides code-level observability, despite your code not running on a host. We can look at this host info tab and see that there is none, because the app is running in a container. Datadog provides log aggregation and filtering for your containers as well. Even if you don't know the exact term that you're looking for, you can begin typing in the query field, and you will be provided with suggestions for autocomplete based on the facets and tags that you're already familiar with from elsewhere. There are times when you really want a real-time view of your log stream as they're produced. Our live tail feature is the equivalent of tail minus f, but it's over your entire account. So right now we're having a problem with our Mongo containers within the service coffee house. So let's filter in and take a look at that. Here we see the exact logs that relate to this. It's like Docker logs or kubectl logs, but better. Additionally, it demonstrates the power of tagging, which you can extend by adding your own tagging schemes. Speaking of tags, if you've ever seen a demo of Datadog, you're familiar with our host map. Part of the wonder of the host map is the power that tags and filters give you to see different ways to slice your view of your infrastructure. Datadog also gives you the same power in our container map. You have the same ability to slice your view of your containers to achieve the kind of visibility that you need at any given time. When monitoring highly dynamic, ephemeral infrastructure, I expect that containers will be replaced frequently. I don't care about the individual container, but rather need to ensure the health of the application as a whole. However, when there is a problem, if I need to, I can select a particular container to inspect it. So, to recap, Fargate lets you run containers in a scheduler without having to manage complex infrastructure. With Datadog, you can focus on running your containerized applications without giving up insight. Finally, this frees you up to solve your business's problems without having to manage infrastructure. With that, I'll turn it over to Robert from 99designs.
All right, thanks Waldo. G'day everyone, I'm Robert McNeil, a senior engineer at 99designs. I'm going to quickly run through some of the experiences my team and I have had on Fargate and APM usage at 99designs. First off, who or what is 99designs? 99designs is the global creative platform for designers and clients to work together. We are a two-sided marketplace for those that design and those that want design. I'm sure you've all heard of Uber. We're like that. However, as we're a year older, I guess you could say that Uber is like 99designs, but for ride sharing. The service that I'll be walking through today is known as Workbench. It is a home for both showcasing the designers and for finding designers to work with on the platform. Workbench itself is a Ruby on Rails application, and as you can see from this simplified service map from Datadog's APM itself, it is backed onto MySQL for database, Elasticsearch for search, Redis for background workers, and it interacts with multiple internal and external services via HTTP. Earlier this year, we moved the service from Docker running on EC2 instances over to Fargate. AWS Fargate has greatly simplified the operational burden of managing and deploying the application and has allowed us to focus more on features and less on deployments and instance management. The move, however, to Fargate didn't come without concerns. With less access to the underlying instances our system was running on, there were questions about observability and debugging. There was discussion even about installing SSH daemons into the Fargate tasks. Thankfully, we didn't have to go down that road as Datadog APM has given us valuable insight into our production systems. So how has APM helped us? I've been able to break it down into three different areas: insights, errors, and optimization. Firstly, insight. How is the service going and what does it do? Whilst the code itself is the source of truth, it is not that easy to keep in your head past a certain size. I personally had moved onto this team and code base earlier this year, previously working mostly in Go code bases. Moving to a large Rails code base, I was having difficulty understanding how everything worked, what the controllers did, where information lived, and which other systems were being hit and why. I would ask my fellow teammates, and I did, but I also needed to see it for myself. Datadog APM's trace view helps with this. Given a controller action, I have many traces to choose from. Going into the trace, I can dig around and really see what the controller is up to. In this particular instance, I wasn't initially sure where work item data was coming from. Was it coming from a database, an external system? Looking at the trace, I could see four things. Firstly, there's a database call to get the user information, including the actual SQL query that was being used. Secondly, there's an Elasticsearch query, which would search and grab work item documents for the current user. Thirdly, there's an HTTP request to an external system to grab the up-to-date work item. And thankfully, with distributed tracing, I was able to dig down into what that system did, including its database. Lastly, updating an internal record and responding to the user. Whilst I could have eventually gathered most of this information digging through the code, I get a much clearer and immediate picture from the trace itself. Knowing what the system does is one thing, but the overall health of the system is also important. One of the features of APM is Watchdog. I've hidden the name on this alert to protect the innocent, but there was an external service having some unexpected latency. Without configuring any monitors or alerts, this latency spike was called out and visible to the whole team. The second area that we use APM for is errors. Whilst we have dedicated error reporting service, it ends up being quite low level. It's useful to have a higher level of the errors in your system too. When looking at a particular service in APM, you're given a list of traced resources. For a Rails application, that maps to controllers and their actions. Sorting this list by error count shows which controller actions are having problems. This can change day to day as the code changes and as dependent services have outages. This combined with the graph of total errors is a nice way to see the health of the system. When looking at a particular trace for an error, it's easy to see how external systems are involved in the cause of an issue. In the trace shown, the user was getting an error when listing their work items. Digging into the trace, we can see a few things going on. Firstly, we're grabbing a document out of Elasticsearch, shown here in green, which references an external REST object. We then call into that system owning the REST object, but that system no longer has that object, so it's giving us a 404. Thirdly, we don't handle that very well, so a 500 is returned to the user. Thanks to the view provided here, we were able to fairly quickly resolve the immediate issue by deleting the stale Elasticsearch document, and then further resolve the problem by properly dealing with 404s when pulling external resources from other systems. Thirdly, we found that using APM makes it easy for us to find both where optimization time should be spent and how to optimize, especially when it comes to interacting with external systems. Before spending expensive developer time on optimization, you'll need to know what is worthy of that time. This is where the trace resources list comes in handy. Naively, one would look at what pager action is getting hit the most and start there. However, looking at which pager action takes the longest is also very important. But better yet, combining these two factors gives you the total time spent in that action. Targeting this gave us our best bang for buck when we went to optimize things. This translates to actual request time, and particularly for a Rails application, we found optimizing for this number gives us better thread and process usage. Once you've figured out what is in need of optimization, entering into a recorded trace shows where the time is being spent. I've picked this trace that fires off 4 external HTTP calls. Looking at the details of the HTTP request spans, I found that 3 of them are independent of each other. Running these 3 external calls at the same time, in this instance, we save about 70 milliseconds or 30% of the response time. So in summary, what we found is that, firstly, Fargate gives us less operational burden and allows us to focus on shipping code and features to the users. And secondly, Datadog gives us observability into the life system. It helps us keep everything running smoothly and directs our day-to-day and future efforts. Thank you.
All right, great. Thank you so much, Robert. And thank you, everyone, for joining us today. You can learn more about AWS Fargate and Datadog at the links at the bottom of the screen. Thank you.